Okay, looking at 6.3 Learning Guide. First of all, number 1 says, what's the name of a five-sided polygon? And you should review in your text. There are several different types of polygons that you'll need to know the name of. So pentagon would be a five-sided. And then if you look at the previous question, 8-sided octagon. Number 2 says, true or false, the opposite sides of a rhombus are parallel. And if you review the definition of a rhombus has two pairs of parallel sides. So these are parallel to each other, and these are parallel to each other. So that would be true. Look at number 2. Beside it, both pairs of opposite sides of a trapezoid are parallel. And actually, the definition of a trapezoid, only one pair of sides would need to be parallel. So these would not be, which makes it false. We could also draw a trapezoid like this, because these are parallel, and then the other two sides are not. Look at number 3. School playground is in the shape of a rectangle, which is 400 feet long and 200 feet wide. If fencing costs 14 per yard, and notice that my units are different here, so pay attention to that. What will it cost to place fencing around the entire playground? So now we're looking at the fencing. That would be perimeter. So perimeter of a rectangle comes from taking 2 times the length, that would give me these two sides, plus 2 times the width, which would include those sides. So I'd have 2 times 400 plus 2 times 200. All of these are feet. So I'd have 800 feet plus 400 feet, which gives me 1,200 feet. We know the cost per yard, so let's change, using dimensional analysis, my 1,200 feet to yards. Remember that 3 feet equals 1 yard. So I'm going to put the feet in the denominator since we'll get rid of that unit. I'll cancel out feet, and I end up with 1,200 over 3 yards, which would be 400 yards. So if I have 400 yards times, we know that our cost is $14 per every 1 yard, then my units of yards would go away. 14 times 400 is $5,600. And notice that the way I've done that is also using dimensional analysis, and the only units left in the problem are dollars. Move on to the next problem, 4A. Find the sum of measures of the angles of a five-sided polygon. Now to do that, we have a formula that is n minus 2 times 180, where n represents the number of sides. So if it's a five-sided polygon, we'll do 5 minus 2 is 180. 3 times 180 would be 540, and that would be in degrees. We would start actually the degrees here. It's times 180 degrees, 180 degrees, which gives me 540 degrees. Okay, then this says, find the measure of an angle of a five-sided polygon. Okay, so we already know that from a pentagon. Draw one real quick. Now, I didn't draw it as regular as I could, but regular means that every angle would have the same measure. So if I drew it just a little bit better, each one of these angles would be exactly the same measure. We already found that the sum was 540. So if we take that sum of 540 degrees and divide it by the 5 sides, it would give me 108 degrees for every angle. Okay. Spelled out a little bit more for you in 4B, the worked out problem, if you want to look at it. Okay, now tessellations. Tessellations, we're mainly looking to see if around a vertex I can have shapes, and whatever those shapes may be, that would add up to be 360 degrees. That way they wouldn't overlap or leave any gaps. So this one says, can a tessellation be created using only regular 9-sided polygons? So first of all, let's find for a 9-sided polygon, I would have 9 minus 2 times 180, which is 7 times 180, or 1260 degrees. So then 1260 degrees divided by the 9 exact same angles, since it's a regular polygon, would be 140 degrees for each angle. So the question is, can I take those 9-sided polygons, the 140 degrees, and lay them out where they wouldn't overlap? Well, if I put one angle down that was 140, and then put a second angle down that was another 140, so far my total is 280 degrees. Well, I couldn't fill the next slot with 140, because 140 would end up being 420 degrees total, and I only have a 360 degrees in a circle. So if I laid the other one out, it's going to overlap onto another part of that. So what you're looking for here is, could I multiply 140 by any number and it end up giving me 360? And we can't. So that would not be possible, because 360 is not a multiple of 140. Now, if the angle measure had been 120, 120 times 3 is 360. So I could have put 3 shapes together and they would have laid out perfectly. Or even 90. 90 times 4 is 360. So that would be what 4 rectangles or squares could tessellate, because at 90 degrees could lay out perfectly and cover an area.